Identifying fall hazards and deciding how best to protect workers is the first step in reducing or eliminating occupational injuries and fatalities caused by falls. The U.S. Department of Labor lists falls as one of the leading causes of traumatic occupational death, accounting for 35% of total deaths in the construction industry. In 2011, the Bureau of Labor Statistics reported 666 fatal work injuries involving falls, which accounts for 14% of the total number of fatal occupational injuries documented that year. In Canada, falls on construction sites are the leading cause of injuries and fatalities. An estimated 60,000 Canadian workers are injured in fall accidents annually, either on level surfaces or from heights. 40% of these accidents occur from a height where fall protection measures should have been taken but were not. These avoidable falls combine to cost Canadian businesses between $20 and $100 million. And in Latin America, falls in the construction industry account for the greatest number of fatalities. Falls from ladders, lifts, and scaffold often involve a number of factors, including unstable working surfaces, the misuse of fall protection equipment, workers slipping, or being struck by a falling object. While these risks are common to construction in all countries, they are exacerbated by the region's climate, such as heat and humidity, and particularly by the lack of adequate protection and training. This is why it's important to always think about fall protection when you're working at height. Fall protection is defined as the methods used to minimize injury due to fall from heights. ANSI in the United States and CSA in Canada are voluntary compliance boards that set standards for the manufacture of equipment, but they do not make laws. However, OSHA is the national governing body in the United States that makes laws with regard to safety while working at height. And according to OSHA legislation, a worker performing a task at least 4 feet from the surface below him is at risk and needs to be protected. Currently, OSHA requires employers to provide fall protection to employees working at 4 feet in general industry applications, 5 feet in maritime applications, and 6 feet in construction applications. However, regardless of the fall distance, fall protection must be provided when working over dangerous equipment and machinery. The preferred hierarchy for fall protection in order of importance should be addressed by the following. Elimination or substitution. This means removing the fall hazard. Passive fall protection. This means isolating the hazard from workers. Fall restraint. This means connecting the worker to an anchor point, preventing the worker from reaching the fall hazard. Fall arrest. This means connecting the worker to a system designed to stop a fall after it has begun. Administrative controls. This is defined as work practices or procedures designed to warn a worker before he or she approaches a fall hazard. It's important to note the differences between fall protection, fall prevention, fall restraint, and fall arrest. Fall protection refers to the overall industry and process of protecting workers at height from falls. Typically, the first image that comes to mind when dealing with fall protection is a worker using a full-body harness connected to an anchor point with a lanyard. This type of system is a fall arrest, or more specifically, a personal fall arrest system. However, this is not the only form of fall protection. In fact, it is one of several choices in most comprehensive fall protection programs. Fall prevention is defined as systems and techniques that eliminate the possibility of a fall, such as guardrails, nets, stair rails, ladder cages, warning lines, and controlled access zones. When installed and used correctly, these systems are usually quite simple and self-explanatory, requiring minimal training, yet still providing a high level of safety. These types of systems are called passive fall protection systems. Fall restraint systems are designed and rigged to eliminate the possibility of workers reaching a fall hazard. Lanyards must be shortened and anchor points must be positioned so workers cannot reach the edge where the potential for a fall exists. Fall restraint systems are often referred to as travel restrict systems. The benefits are obvious. If the possibility of a fall has been eliminated, the potential for serious injury has also been effectively eliminated. And the need for rescue has also been eliminated. It is important to remember to take all related hazards into account when using a fall restraint system. Often a fall restraint system is set up to protect a worker from one hazard, and then it is later discovered that the worker could also travel to another point, not in his immediate work area, where the potential for a fall exists. In these instances, the system should also be designed with fall arrest considerations in mind. While fall prevention protects the worker by eliminating the possibility of a fall, it is recognized that engineering cannot always eliminate the risk of a fall. In such instances, fall arrest systems are normally implemented. Unlike fall prevention, fall arrest assumes the inevitability of a fall and is designed to arrest a fall and to minimize injury in a fall event. Even with this assumption, it must be stressed that fall arrest systems are not a replacement for care and attention in the workplace. A common problem experienced during the early stages of a fall arrest program is the increase in falls due to workers feeling invulnerable and becoming careless. This can often be dealt with through proper training and diligent communication. A typical personal fall arrest system incorporates 4 components, often described as the ABCDs of fall protection. When used together, the anchorage or anchorage connector, body support, and connecting device form a complete system for maximum worker protection. But don't forget about another required component of any fall protection program: the descent, rescue, and retrieval of a fallen worker. So let's recap what we just said. Anchorage. Anchors are a secure point of attachment. Anchorage connectors vary by industry, job, type of installation, and structure. They must be able to support the intended loads and provide a sufficient factor of safety. Body support. The body support is typically a full body harness. Harnesses distribute fall forces over the upper thighs, pelvis, chest, and shoulders. They provide a connection point on the worker for the personal fall arrest system. Connectors. Connectors such as shock-absorbing lanyards or self-retracting lifelines connect the worker's harness to the anchorage. Descent and rescue. These are devices used to raise or lower a fallen injured worker to safety or retrieve him from a confined space. We'll discuss the components of a personal fall protection system in more detail later in this video. So now that we know about the ABCDs of fall protection, we can talk about the fundamentals of fall protection and what you need to consider when setting up a fall arrest system. These include arresting forces, required fall clearance distance, and swing fall. Let's begin by taking a closer look at arresting forces, the actual forces generated on your body and the system when you fall. In this demonstration, we dropped a 220-pound mannequin attached to a 6-foot, non-shock absorbing rope lanyard. When the mannequin hits the bottom of its 6-foot drop, you can see the violent forces at work. Let's take another look in slow motion. The amount of force generated on that 6-foot drop is measured at over 5,000 pounds. This exceeds regulations and is more than enough force to cause serious injury to a worker. According to OSHA and ANSI standards, the maximum arresting force can be no more than 1,800 pounds. ANSI limits the deceleration distance to no more than 48 inches for standard 6-foot energy-absorbing lanyards, and 60 inches for 12-foot free falls when specialized energy-absorbing lanyards are used. We'll discuss deceleration distances in more detail in just a few moments. Let's talk about calculating your required fall clearance distance. We'll begin by defining free fall. Free fall is the first factor in calculating your required fall clearance distance. Free fall is the distance you'll fall before your fall arrest system begins to slow you down. Properly designed fall arrest systems protect workers from contact with any lower level or obstruction, with no more than a 6-foot free fall. This is why the proper calculation of fall clearance distance from your anchor point is so important. Let's take a closer look at what we're talking about. If you're using a 6-foot lanyard connected to the dorsal D-ring of your body harness, and you connect the other end to an anchorage point at the same height, how far will you free fall? In this case, you'll free fall 6 feet, because that's the length of the lanyard that's connecting the 2 points together. However, how far will you free fall if you're connected to an I-beam 4 feet below your dorsal D-ring? In this case, you'll see a free fall of 10 feet. That's 4 feet to the I-beam, plus the 6 feet of lanyard. Here you will have exceeded the typical 6-foot free fall. Free fall is the first factor in calculating your required fall clearance distance. To determine if we have enough space below us, we must add our free fall plus our deceleration distance. Deceleration distance is defined as the distance it takes for the energy absorber to activate and slow your fall. The actual deceleration distance is based on the user's weight, the free fall distance, the type of lanyard used, and applicable standards. User instructions for energy-absorbing lanyards will provide deceleration distance charts to help determine specific system performance. Ideally, the maximum deceleration distance is factored in when determining the required fall clearance distance. Let's look at the following animation to illustrate fall distance closer. In this demonstration, a worker is connected to an overhead anchor point with a 6-foot lanyard. When the worker falls, the energy absorber on the lanyard activates, creating a deceleration distance of 4 feet. Regulations allow us to add 1 foot of deceleration distance for free falls over 6 feet up to 12 feet. For a person weighing over 310 pounds, specialized equipment is available to cover workers up to 420 pounds based on OSHA regulations. In Canada, regulations allow for up to 5.7 feet of deceleration distance when using a CSA-approved E6 compliant lanyard. At the onset of a fall, the worker's harness will shift slightly on the body, and the dorsal D-ring may slide upwards on the harness straps. This combination of movement is known as harness stretch. This factor, plus the worker's height, is typically measured at 6 feet. The safety factor is defined as the distance between the worker's feet and the level below at the instant the fall is arrested, prior to any bounce back. The typical distance is 1.5 feet. So in this demonstration, our required fall clearance distance is 17.5 feet, using a typical 6-foot lanyard with a 6-foot free fall. To reiterate, the required fall clearance is calculated by adding the length of the 6-foot lanyard to the 4-foot deceleration distance, plus the 6-foot height of the suspended worker, and the 1.5-foot safety factor. In this section, we will examine the types of falls, their hazards, and how to reduce the risk of injury in each scenario. Free fall is the distance from the point where the worker starts falling to the point where the worker's fall arrest system begins to slow him down. The greater the free fall, the greater the deceleration and total fall distance. You can minimize the free fall by anchoring above your head as high as possible, using the shortest lanyard length possible. In this demonstration, a worker is connected to an anchor point above his head, but he has positioned himself off to the side of the anchor point and accidentally slips off the edge of the work area. His fall arrest system stopped his fall. However, due to the angle, his fall caused him to swing like a pendulum. In this situation, the fallen worker only needs to be rescued because he didn't strike anything on the way down. In this second demonstration, we recreated the same fall as before, but this time the worker is anchored to a steel I-beam at his feet. This is a much more dangerous fall because the greater the angle from your anchorage, the wider your swing fall will be, and the greater the impact when you contact obstructions. In this demonstration, the worker falls significantly farther faster before slamming into a wall below, causing serious injury. In this situation, the swing fall injury becomes just as serious as falling the same distance straight to the ground. He not only needs to be rescued, but he also needs immediate medical attention. You can reduce your potential free fall distance by using a self-retracting lifeline. When anchored above your head, a self-retracting lifeline extends and retracts as the worker moves about his recommended work area at a normal pace. But if a worker steps out of his safe work zone and a fall occurs, the speed sensing brake will activate, stopping the fall within inches and reducing the forces imposed on the body in most cases to 900 pounds or less. In this situation, chances are very good the worker may be able to rescue themselves, and the potential for injury is reduced. However, if the impact indicator on the SRL's snap hook has been impacted, the SRL must be taken out of service and sent to an authorized repair facility for recertification and repair. We talked about the ABCDs of fall protection earlier. Let's recap what we talked about. A typical personal fall arrest system incorporates all of the following. Anchors are a secure point of attachment. Anchorage connectors vary by industry, job, type of installation, and structure. But some examples include structural steel members and precast concrete or wood trusses. Inappropriate anchors include fluid pipes, handrails, or electrical conduits. Suitable anchors must be able to support extreme forces generated in a fall. There are two anchorage classes considered for use in a fall arrest system: certified or engineered anchorages and non-certified or improvised anchorages. Non-certified anchorages must be capable of supporting at least 5,000 pounds per employee. But a certified anchorage must be designed, installed, used, and maintain a safety factor of at least 2, under the direction of a qualified person. Body support. Harnesses distribute fall forces over the upper thighs, pelvis, chest, and shoulders. They provide a connection point on the worker for the personal fall arrest system. When donning the full body harness, it must be adjusted to fit you properly. It should be snug, but comfortable. The sub-pelvic strap should be positioned directly under the buttocks. This strap and its proper placement are crucial. It is the sub-pelvic strap that distributes much of the energy generated in a fall to the structural part of your body. The chest strap must be fastened securely, and the dorsal D-ring should rest between your shoulder blades. Once your full body harness is properly fitted, you'll get freedom of movement, comfort, and maximum protection in a fall. Connectors, such as shock-absorbing lanyards or self-retracting lifelines, connect the worker's harness to the anchorage. Lanyards are made of rope, webbing, or cable, but when used for fall arrest, they must incorporate a shock absorber. Additional anchor connectors include snap hooks and carabiners. These are available in a wide variety of shapes and sizes, but all of them must be self-locking to reduce the possibility of a rollout or accidental disengagement. Although auto-locking snap hooks prevent rollout, they should still be coupled with much larger diameter hardware to prevent forced rollout. Forced rollout may occur when a snap hook is attached in a manner that enables the side of the gate to be forced open. To be safe, You always want to check with the manufacturers to make sure the connections you make are compatible. All snap hooks chosen for fall protection or rescue operation should be simple to operate to ensure they will be used correctly. They should have user-friendly, one-handed operation even when wearing large gloves. Workers should always make sure they achieve positive connections between components of their personal fall arrest systems, especially when visual confirmation is not possible. For example, the attachment of a snap hook to a D-ring on the back of a harness. And as a general rule, all connecting components and assemblies must have a minimum strength of 5,000 pounds, even those used on shock-absorbing lanyards. Rescue and descent devices are used to lower an injured worker to the ground or retrieve him from a confined space. It is imperative to have a rescue plan in place at your job site in the event of an accident. And the plan must be reviewed and practiced on a regular basis. Calling 911 isn't enough. Your employees need to have the necessary tools, training, and skills to assist your staff or local rescue professionals. It's also important to remember that the rescue should be kept as simple and safe as possible, putting the fewest workers at risk. In the heat of the moment, potential rescuers might panic and overlook important aspects of their training. To prepare for the potential of a rescue, a thought process needs to be established that reminds every worker of the hierarchy of a rescue. Self-rescue. Self-rescue means climbing or pulling yourself to safety. Assisted self-rescue. This means you're using a ladder brought to you by a coworker. Mechanically aided. A mechanically aided rescue means using a lift or bucket truck to rescue you. Rescue pickoff. A rescue pickoff is a last resort because it requires the most time to accomplish and the most skill to safely perform a rescue. However, rescue as the last component of a fall protection plan is a good problem to have. A rescue situation means the worker was wearing his harness and attached to an anchor, thus making the fall protection plan a success. All your fall arrest equipment needs to be properly maintained. You should personally check all your components before each use and have an annual inspection performed by a competent person. While checking your equipment, be sure all the hardware is free of cracks, burrs, or corrosion, and all the working parts move freely, including the buckles and snap hooks. Be sure that all the plastic pads and keepers are in place and free of cuts or cracks. The webbing should be free of any cuts, frayed, or broken fibers. Check for tears, abrasions, burns, or discoloration. All the stitching should be intact. Check for pulled or cut stitches. Broken stitches may indicate that the equipment has been impact loaded and must be removed from service. Inspect all the labels to see that they are present and fully legible. If the labels are not, they should be replaced. Upon final inspection, record the results and date in an inspection log. If the inspection reveals any defective component, remove it from service immediately and have it repaired or destroyed. We've covered a lot of ground in this video, so it's important to keep your employees trained. Keep up-to-date copies of the latest OSHA, ANSI, and CSA standards, and inspect your fall protection equipment on a regular basis. This video is just a start to get you thinking about fall protection, but there's a lot more to think about. That's why we recommend every employee participate in a comprehensive training program to create the knowledge and skill base necessary to protect workers at height. Because at the end of the day, we want every worker to go home safely, so you can live your life to the fullest tomorrow.